Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to solve compound inequalities. Do not forget to visit our website at mathgotserved.com for access to a wide variety of math tutorials ranging from algebra all the way to calculus. All right, let's write down the instructions for the examples we are going to be doing. We're to solve each inequality and graph, okay? And graph the solution. All right, let's take a look at question 1. For problem 1, we have the compound inequality 7n minus 9 is greater than or equal to negative 30, and 9n minus 8 is less than or equal to 64. Now, when you have a compound inequality that has an and, or can also be referred to as a conjunction, you can write the final answer as a combined inequality. All right? So let's not bother ourselves about that now. Just keep that in mind, that we can sandwich the solution, the variable between two values at the end. But let's just focus on how to solve these two components of the compound inequality. Okay, so let's shift our attention to the left side, the inequality on the left. We'll solve it like a typical linear inequality. Our goal is to isolate n. To accomplish that, we're going to add 9 to both sides and divide by 7. Okay? Let's go ahead and do that. Add 9 to both sides. That yields 7n is greater than or equal to negative 21. And finally, divide both sides by 7. And then we'll have n. Negative 21 divided by 7 is negative 3. So the question now is, do we switch the order of the inequality? The answer is no. When do we switch the order of the inequality? We switch the order of the inequality when we divide by negative. Okay? So we divided by a positive number here, so the inequality remains unchanged. Now let's shift our attention to the right side. Let's go ahead and isolate n here. We'll accomplish that by 2 steps, just like we did earlier. We're going to add 8 to both sides and divide by 9. So we add 8, and then we have positive 9n is less than or equal to 72. And then we'll divide both sides by 9. Divide both sides by 9. Since we're dividing by a positive number, the inequality remains unchanged. Okay? 72 over 9 is 8. And then the conjunction is and. Now, since this is an and or conjunction, we can combine these two inequalities into one. Okay? So we put n in the center. This is n is greater than this, so the variable that n is greater than goes to the left, negative 3. And then we have less than or equal to. Remember, this inequality is always pointing to the smaller of the two, right? So this inequality is pointing to negative 3. So when we switch it around, it's still pointing to negative 3. Okay? And then in this case, n is less than 8. This is already n, so we have the inequality pointing to n, and then we have 8. So these are the two ways that we can express our solution. Okay, so we can express it as a conjunction or a combined inequality. These two mean exactly the same thing. Okay? Now let's go ahead and graph our solution region. Our solution region is the region bounded between -3 and 8, including -3 and 8. Okay? Let's go ahead and graph that. So we have 0. Let's put 0 to the left a little bit. 1, 2, 3, -3. And to the right, we're going to go all the way to +8. Okay, so this is -3. This is 0. 1, 2, 3, 4, 5, 6, 7, 8. And this is +8. So we're going to have a closed circle at the endpoints. Why aren't our circles open? Because we have the inclusion line beneath our inequalities. So since n is sandwiched between these two values, our solution region will be this interval right here. All right, let's take a look at question number 2. So for number 2, we have 6k minus 8 is less than -62, or -10k minus 5 is less than 25. All right, now this cannot be expressed as a combined inequality. This is a disjunction, so we have to solve them independently. All right. All right, let's take a look at the inequality to the left. We want to solve this for k. We're going to add 8 to both sides and divide by +6. All right, let's go ahead and do that. Add 8, add 8. We have 6k is less than. Now, since the signs are different, we'll subtract and keep the sign of the bigger one. All right, so we subtract this from that. We have -54. And then divide both sides by 6. Since we're dividing by a positive number, the inequality remains unchanged. -54 over +6 is -9, because we're dividing two numbers with different signs. On the right side, we'll add 5 and divide by -10 to get k isolated. So we add 5 to both sides. That yields -10k as less than 30. To get k isolated, we'll divide both sides by -10. Now, since we're dividing by a negative number, we're going to switch the order of the inequality from less than to greater than 3. Actually, -3, since you're dividing a positive and a negative number. Anytime you divide numbers with different signs, you always end up with a negative result. This is a disjunction, so we have or. Can we combine these two inequalities into one sandwiched inequality? The answer is no. You can only combine them when you have an and situation, which is not the case here. So what does that mean? We already have our answer. Okay, k is less than -9 or greater than -3. Let's go ahead and graph the solution on a number line. So we have, put 0 over here. 1, 2, 3. That's -3. Again. Now, is our circle going to be open or closed? Since there's no line underneath the inequality, our circle is going to be open. Greater than goes in the right direction, the direction of the increasing values of numbers on our number line. Now let's shift our attention to negative 9. So negative 4, 5, 6, 7, 8, 9. Negative 9. We also have an open circle here because we do not have the line of inclusion, and our arrow points to the left because we have a less than situation. Okay, so this is a graph of your solution, and this is your solution right there. Thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials such as this. Also, visit our website at math.serve.com for access to a wide variety of math tutorials. If you have any questions, comments about this video, or if you would like to request other tutorials on math, feel free to include your request in the comments section below, and we'll be glad to assist toward the best of our ability. Thanks again for watching, and have a wonderful day.